Good day, Algebra. We are moving on to PO59, which is all about the quadratic formula. If there are three formulas that are going to serve you best to know after your mathematical career, Solver's form is one of them. You already covered that. Would you interrupt Jimmy Fallon in the middle of his monologue? No. Quadratic formula is the second one. That's what we're doing today. And the Pythagorean theorem, Jack, warning for you. The Pythagorean theorem is the third one, and we'll cover that one next year in geometry. But what the quadratic formula does, it is used to help with solving quadratic equations. And remember, we say we solve quadratic equations. Damien, warning for you. What are we talking about here? What does it mean to solve a quadratic equation? Kind of. Find the x-intercepts, right? Not just x, but specifically the x-intercept. And so far, we've covered three ways to do that, all in PO55. Depending on what type of equation you have, you can use the order of operations. What type of equation lends us to the order of operations method? What's the form? Damien?
I have a question.
Yes.
Why did you say 55 when...
I'll explain it later. I'll explain it later. Because you're wrong. Yeah.
AX plus C?
Yes, so ax squared plus c. Okay, that's the formula. There's no bx term. That's when you use that order of operations method. How about the GCF? What form of equation would you use the GCF method for? Elliot? Ax squared plus what? Bx. Okay, ax squared plus bx. There's no c term. We can't use order of operations here because those x's, they aren't like terms. There are two of them that can't be combined. And so we have to pull out that greatest common factor. And then when would you factor? When would you factor? What form of equation would you factor? Aiden?
Ax squared plus bx plus c.
Yes. Ax squared plus bx plus c. Well, it's got all three of them. And that's where you look for the two sets of parentheses and all that sort of stuff. Okay. We're not going to cover completing the square quite yet. That's kind of a bonus method, but given that it's May 9th, we kind of got to scoot along a little bit. But the quadratic formula is nice because the quadratic formula works regardless of what form of the equation you have. So that's a plus. And you know how those, when you factor equations, sometimes you run into those prime ones that you can't factor? So quadratic equation works for those two. Okay? So the plus is that if you remember only one thing, for how to solve a quadratic equation, it's the quadratic formula. The downside, though, is that the quadratic formula looks like this. It's negative b plus or minus the square root of b squared minus 4ac all divided by 2a.
What?
There are pros and cons to everything, and this is the cons. Okay, Beckman, double warning for you. You're at 2. All right. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Yes, sir.
Why is it just all three of them combined?
What's that?
Why is it just basically every formula combined?
Because it's the
Oh yeah, so Aiden's probably noticing here, there's a lot of similarities with other things we've already covered, right? Where have we seen b squared minus 4ac before?
The last objective.
The last objective, right? That's the discriminant. Where have we seen negative b over 2a before?
In the things where you find
The x value of the vertex.
Parabola.
Okay? So what we're doing here is we're kind of combining that vertex formula with the discriminant all in one glorious formula that will tell us what the x-intercepts of any parabola are. Okay? Sit left. Oh, you got the rocking chair. Never mind. Okay. Are we all good? I mean, am I all good? I mean, have you written it down?
Yeah.
Okay. Just like any other formula that we've covered, the A, B, and C all come from the equation you have. So again, it's important to remember that these equations are in ax squared plus bx plus c equals 0 form. Okay? And I recommend, especially when you start, write down what your A, your B, and your C values are. So identify those first. Our A value in this equation is what? 1. That coefficient to x squared, which isn't written, so it means it's a 1. Our B value is 5. And our C value is, well done, negative 104. Okay? So, from here now, it's just kind of plugging stuff in. Elliot, yeah.
How is it plus and minus?
How many x-intercepts do we have to be open to having in a parabola? 2. Right? So the plus minus is there to get both of those. Okay?
Is there a plus minus?
Hey, folks, there's not. Yeah.
So to do this, would you do -5 plus minus? Like you put plus and then a minus or minus and
No. So this is not something that you can just plug into your calculator, right, and get both answers. You have to kind of do it piece by piece. So the work I'm going to show is kind of how you do that step by step. You kind of solve it in 3 parts. Okay. When you get good with the calculator, then you can kind of do it in fewer steps, but you're not good with calculators yet, right? You're still learning about parentheses and the root symbols and things like that, order operations. So I would not trust yourself yet with the calculator to get it more or less directly. So we're going to do it in parts. Okay. So the first step is we're just going to plug things in, right? Negative b is going to be a -5 plus or minus the square root of 5 squared, and I'm going to put my 5 in parentheses just like I always tell you to do when you square, just so if it's negative and you need the parentheses, you don't forget. If you always put the parentheses in, then you're not going to forget them when they're actually required. Okay? Minus 4 times our a term, which is 1, times our c term, which is negative 104. Let's make this too short. Let's kind of extend that longer. Okay? And this entire thing is then divided by the product of 2 and a, or 2 times 1. Okay?
Whoa.
Now, the part that we're going to solve first here is the discriminant, which you've done before. You've done b squared minus 4ac. You know how to put that into a calculator. Okay? So go ahead and just tell me what the value is. Don't take the root of it yet. We'll get to that. But just what's the value under the root? What's that b squared minus 4ac part equal? Tyler.
441.
441. Do you have a second on that?
Yeah. Yes.
Okay. So our next line is going to read -5 plus or minus the square root of 441. And we can do the denominator in this step also, might as well. It's easy to do. 2 times 1 just gives us 2. Okay? Already it's much simpler. Okay? Take care of that discriminant first, which you've done. And then the denominator, and already we've got something that's much easier to work with. Still can't go to the calculator quite yet, right, as far as to solve the whole thing. Our next step is to take the square root of 441.
Where's the square root?
Your square, this is why you can't, right, we're still learning about the calculator. The square root button is above your x squared key, so you need to press the second function first, okay? Notice how the when you use the square root, it automatically gives you a parenthesis. So when you put your 441 in, close it. Okay, it gives you one automatically. You'll then want to close it. Lisa. 21, Elliot.
I got 445.
Okay, so check your calculation again. Did you only do what's under the root, Elliot, or did you include the -5 out in front?
I did not include the
Okay, did you get 445 again? Take a look. You put -105. It's a -104. Is what happened there. Okay? Folks, 3, 2, 1, you are quiet. Damien, turn around, please. Thank you. The root of 441 is 21. So our next line, our next piece of this is going to be -5 plus or minus 21, all divided by 2. Okay? So first, we did the discriminant. We multiplied 2 times a. That was easy enough. Then we took the square root of, in this case, 441, and we're now left with -5 plus or minus 21, all divided by 2. Questions on how we got to where we are? Okay. Now's when we solve. Here's when we use that plus minus here. And because we're looking for 2 answers, our first answer is going to be -5 plus 21 divided by 2.
And that
Okay.
makes minus 2.
And our second answer is going to be -5 minus 21 divided by 2. So you actually solve 2 different equations here, 2 different expressions, one where you're adding 21 and one where you're subtracting 21. And so maybe you can do this mentally. If you're not, if you're using a calculator, make sure you are putting parentheses around that numerator. And if you don't, you will get the wrong answer because your calculator will divide 21 and 2 first before adding it to or subtracting it from -5. So what do you get? -5 plus 21 divided by 2, Vince? 8. One answer is 8. -5 minus 21 divided by 2, Aiden? -13 are your 2 solutions. If you are unsure of or unable to get 8 and -13, please raise your hand and let's chat. Because it's a real bummer to do all the work, right? And then make a mistake on the very last step. Damien?
I have a question
Yeah.
on how you got the 21 from -5 plus square root of 441.
The square root of 441 equals 21.
Yeah, I don't. Did you just? Oh, you just square root of 441.
Yes,
Oh,
that's exactly what
fine.
we did. Okay? Other questions? Make sure you put in parentheses around that -5 plus 21 if you're using a calculator. Otherwise, your calculator will do a different order of operations what you want it to do. Yeah.
Do we have to put those 2 equations, or can we just put -13?
The more steps you skip, the more corners you cut, the more opportunities there are for mistakes. You're doing this for the very first time. It takes an extra probably 15 seconds to write both of those out. It's worth it.
Oh, we
Okay?
don't have to. So we should do.
You should write all of this out.
Oh yeah.
Yeah.
So I'm
Arlene.
answering.
Will there ever be a decimal answer?
Usually, yes. Yes. In fact, if you do get integer answers like we had here, that means you could have factored this from at the start. I didn't want to give you a nasty decimal one to start out with because we're just learning the process here. But if you ever use the quadratic formula, like, oh, that worked out nicely, that means you could have factored it. Okay. The next one, though, I'm not sure we can factor. So this is going to be even more fun. Okay. Here we go.
Mr. Schultz.
Yes.
So we on our answer, we can just write out 13 and 8.
-13 and 8. That is your final answer, yes. But if you turn in a test with only answers on it, I'm going to have a lot of questions. Lots of questions. Yeah. All right, here we go.
What if I can
A, B, and C. What is our A value? Kylie. 2. What is our B value? Vince. 6. What is our C value? Ellen. 5. Okay. Let's start by plugging the stuff in. -b becomes -6 plus or minus a square root of b squared, or 6 squared, minus 4 times a, I made it too short again, times c, okay, all divided by 2 times 2, or 2 times a. B squared minus 4ac, all divided by 2a. Which piece of this do we do first? Elliot?
do inside of the square?
AKA the discriminants, right? And also because it doesn't affect things and it's easy to do, we'll multiply the denominator in the same step just to get it done. So we do that and we get -6 plus or minus the square root. What is 6 squared minus 4 times 2 times 5? What do you get, Noah? -4?
Second that.
I got that as well.
First, now we made the root too long.
I
Know
got
that.
syntax error.
Okay? If you got
Finally
syntax
got
error, you may have
Never mind.
used a negative or a subtraction symbol instead of a
No,
negative.
no,
Oh, sorry. Negative subtraction. Yeah.
So since you can't do the square root of a negative number, would it do the 2 with the little I?
What did this discriminant tell us again?
I don't know.
How many
extra
there are?
How many x-intercepts there are? What happened in 58, Jack, when we had a negative discriminant? What does that mean?
That means that there
It's like,
was
it's like this, like,
Zero x.
I'll bring up here. Oh.
Lisa, it meant there were no x-intercepts, right? And in 58, we didn't care about what the actual value was. We only cared about whether it was positive, 0, or negative, right? But any negative discriminant means it's not going to have any x-intercepts. Here's the reason why. Because, second warning for you, because the discriminants being a part of the quadratic formula, if the discriminant is negative, and now you're asking us to take the root of a negative,
Oh, no.
what does that mean?
J.
It's a made up number, right? The root of a negative is always imaginary. So, does it mean that this is not a parabola? No. If you do this in your calculator, you'll get a syntax error or a domain error or something like that. All it means is that there are no x-intercepts. Okay? All it means is that there are no x-intercepts. So if you are solving the quadratic formula and you get a negative value under that, that's why I do it first, right? Because if that ends up being negative, it means there are no x-intercepts. You don't need to go any further. Because if we're solving for the x-intercepts and there aren't any, then we stop. Vince, warning for you. You're whistling. Yes. Okay.
So that's it.
That's it.
Alright, so
Next one.
Let's go.
Let's look at our A. Let's look at our B. Let's look at our C. What's our value for A?
Negative.
-4. What's our value for B? -5. What's our value for C?
-1.
-1. Okay? The negative signs do play a big part here because in the quadratic formula, like we saw with the vertex formula, if that B value is negative and you take a negative B, what's it actually going to be? B on the front. Run. Positive. So a -5 is actually going to be a +5. When you go to do your discriminants and you square that -5, here parentheses are required. Because you want that negative sign to be squared as well. Which is why, again, I recommend always using parentheses, because here when you need it, if you're not used to doing them, you might forget. So it's worth it just to always put parentheses around anything that you are squaring. -4 times A, which is -4, times C, which is -1. And all that is being divided by 2 times A or 2 times -4. Okay? Let's go with that discriminant first. Jack?
I think the discriminant is 9.
9?
Second that.
Do you have a second on that one?
Yes.
Okay?
Wrong?
That means that someone.
Oh, I mean, it's wrong.
No, it means that someone agrees with you.
Oh.
If you second something, it
Yeah,
means.
it always meant they were.
Yeah, no.
You were wrong.
Okay? If you got -41, then you did not put parentheses around -5, and you only squared the 5 and not the -5.
Regular 41.
If you got regular 41, then you forgot a negative sign somewhere in here. Thank you. Yellow.
Oh, yeah.
Hi. He is not. Yeah. Yep. Bye. Yeah. When you're using a calculator, you got to pay very close attention that you're doing exactly. You're telling it to do what you want it to. Okay.
You
Yeah.
have to put the negative signs from the, so when it goes -5 squared -4, you put them negative sign with the 4.
This subtraction sign with the 4. Yes, it belongs to the 4.
Okay.
Yep. So 9 is what you should get. So 5 plus or minus the root of 9, all divided by -8. Anyone still confused how we got 9? Anthony, where'd you get?
Domain error.
Okay.
I got it.
Double check that you've written this, type it in exactly how we have it here. Elliot?
I have the.
Okay, just hold on. Yeah, don't root it yet.
Oh, no.
Do just the discriminant part first. And so what do you get when you do just that -5 squared minus 4 times -4 times -1? Do that first. Make sure you get it. Anybody else have any calculator questions? What'd you get?
9.
Good. Okay. Now, yes, Alex. Okay.
Second.
Now we are doing the square root of 9, which if you need a calculator to do the square root of 9, I have other questions for you. But you need to do the second function, and the root symbol is above your x squared key. Right? So you first press the second button and then x squared to get the root symbol. You put in 9, you close your parentheses, you press enter, and then you'd realize, oh, I could do that in my head. And then next time you do it in your head. But anyway, that gives us 5 plus or minus 3, all divided by -8. Okay. Where do we go from here? Ellen.
So first you could do 5 plus 3 and then divided by -8, which is -1.
Okay. First answer is 5 plus 3 divided by -8, which equals 1. And our second answer would be 5 minus 3 divided by -8, which equals -0.25 or -1/4.
Should we put it in fraction time?
Okay. Fraction or decimal. An answer like that, -0.25, a fraction. We're going to get some nasty decimals coming up. So round near 100th is usually the rule of thumb.
Like that means 3.
What's that?
That means 3. Oh, sorry.
100th is 2.
Oh.
Alex?
How do you square root of 0?
Root of 0 is just 0.
No x intersect.
Right? No.
Oh,
Root of 0 does
one
not
x
mean there are no x intercepts. There's only one. Because plus minus 0, it doesn't change the value. Right? If you add 0 or subtract 0, it doesn't change, so that's why there's only 1. Lisa?
So the negative is 0.25.
Yes. Sorry, I got kind of squished there, but yes, -0.25. Okay? Let's look at one of the next page. And let's tackle.
Oh, great.
How many pages are there for this?
1.
Just one? Excellent. Excellent.
Can we do like 3 of them?
We'll do as many as we can. We've got 10 minutes left, but a lot of that depends on kind of how well you let me do my thing. Okay? Starting with identifying the A, the B, and the C. Our A value is 8. Our B value is? Our C value is?
-1.
Okay? Now we go ahead and plug that into the quadratic formula. So we have a negative B, or -8, plus or minus the square root. C, it's a good thing you're paying attention. -6 plus or minus the root of b squared, or 6 squared, minus 4 times a, which is 8, times c, which is -1. all divided by 2 times a, or 2 times 8. First things first, the discriminants. Inside the root, what do we get? 68. Is this one going to work out pretty?
No.
No, it is not. Okay? So negative 6 plus or minus the root of 68. All divided by, we can do our denominator as well here. All divided by 16. If you are not getting 68, please raise your hand and we can talk about what. It's essentially 6 squared is 36. I'll put the numbers up below here. 6 squared is 36. A negative 4 times a positive 8 times a negative 1 is a positive 32. And 36 plus 32 is where 68 comes from. Okay. Take the root of 68 in your calculator. It does end up being a nasty decimal. Round nearest hundredth, and we get 8.225.
Yes. Yeah.
Okay. So, our first answer comes from Damien?
Oh, wait. I don't know my answer to that. Oh, wait.
What would you set to find it?
For the plus 1, is it. Never mind. It'd be negative 8.
The plus 1 is negative 8.
Yeah, like using a plus 9.
So to solve this now, you'd say negative 6 plus 8.25
Yes.
divided by 16.
Yes.
I don't think we get negative 8 from that.
Oh, no.
Well, negative 6 plus 8.25 will be around 2.
Yeah.
And 2 divided by 16 would be like 1/8. Right? It wouldn't be 16 divided by 2. We wouldn't flip our fraction around. What decimal do we get when you take negative 6 plus 8.25 and divide that by 16? Noah? 0.14?
Yeah.
Yes.
Okay. Our second answer is going to be the same thing, only this time minus 8.25. And we divide that by 16. Elliot?
Negative 0.89.
Negative 0.89. Do we have a second on that?
Yes.
And there we have it. Okay? So when you get answers like this, when this root is not a perfect square, that means it would be a prime. If you try to factor it, you wouldn't be able to. Okay? And so to get around that, to get around those prime ones, we can use the quadratic formula. You get pretty nasty answers. Okay? How can you check this to make sure it works? How can you check it? Wyatt?
Oh, I just had a question.
Go ahead.
Can we work on this on like a different page and then show you so we have some more?
Yes, if you need more space to work, you can use the backside or whatever, separate sheet of paper. Yeah. How could you check this to make sure it works? Aiden?
Plug it into the equation.
Yeah, so you take your 0.14, you go back to the top, you take 8 times 0.14 squared plus 6 times 0.14 minus 1. And you won't get exactly 0, but why is that okay? That you won't get exactly 0, Max?
Because we rounded our.
Because this is a rounded answer. And if you use a rounded answer back in the original equation, you'll get really close. You know, like 0.02 or maybe like 0.1, right? It'll be really, really close, but it won't be exactly. If you get like, 2 as an answer, that's not close enough. So it'll be very, very close to 0, but that's how you can check to make sure that you are correct. Okay? Questions on the quadratic formula? Yeah.
If there's a 0 in like one of them, where you put it in the.
Yes. So I said earlier that this can work for any form. When we will go down to this one here, 5x squared minus 3, you could use order of operations. But why would you when you have the quadratic formula, right? Our a value is 5. Our b value is 0 because there isn't a b. And our c value is negative 3. So when you go to the quadratic formula, it's going to literally look like this. negative b, or negative 0, which is just 0, but negative 0 plus or minus the square root of b squared, or 0 squared, minus 4 times a times c, 4 times 5 times negative 3, all divided by 2 times a, or 2 times 5. So if there's not a term there, the variable value will be 0, and you plug it in the formula just how you would otherwise. Okay? It'll work itself out. And what do you know about the solutions of this type of equation?
Oh, one of them's always zero.
Lizzo?
One of them's always zero.
Nope, not this type. That's ax squared plus bx. Then if there's no c term. What about the ax squared plus c? Kylie?
There's gonna be, the answer is gonna be opposite.
You'll get 2 of them, and they'll be opposites. Right? So if you recognize that, and you go through the quadratic formula, and you don't get opposites, then you know you've done something wrong. Okay? And the reason why you get opposites is because you're starting from 0, which is like the middle of the number line. You add a value, and then divide by 2a. And on the other side, you subtract that same value, and divide by 2a. It's just going to be the same distance on the other side of 0, thus opposites. Lisa?
What if you put like root 0?
The root of 0 is just
Zero.
which means you're only going to get one x intercept, right? Because if the discriminant equals 0, there's only one x intercept. Okay?
That's okay.
How are we feeling? Are we feeling better than when I first wrote it up on the board?
Yeah.
Yeah, it's not so bad. It's not so bad. Okay? Sophie,
Last one. Last row.
go over the last one.
The last couple.
Do another one.
Right? So in this one, it's not in standard form, right? It's not in ax squared plus bx plus c form. So let's put it there. How would we put this into ax squared plus bx plus c form? Crab claw, foil, box it, whatever you want to do. You'd start here, and you'd rewrite it to be x squared plus 26x plus 169 equals 25. Okay? Still not in standard form, though. So what would our final step be here, Max?
You have to take the 25 out.
Move the 25 over so that it equals 0. Right? And now you're good to go. Now you're good to go. Other questions? Comments, concerns, complaints, compliments, congratulations, criticisms? Yes.
That's right.
Thank you. I haven't worn it in a while. I thought I lost it. I found it.
We have no homework.
You do have homework. Ellen,
How much time do you have to work?
you have 2 minutes, maybe 2.5, to work on your assignment.
Okay.
What's the assignment?
The rest of the page.
In
Yeah.
the bottom?
That's not
Well, we answered this one. You probably recognize the discriminant is embedded in the
We have
quadratic
to
formula.
answer it.
I probably still on that thought. We'll get to it later. Now that you've seen the quadratic formula, explain mathematically why the sign of the discriminant determines the number of x-intercepts the parabola has. So, thinking about what a positive discriminant means, what a zero discriminant means, what a negative one means, why does that make sense now that you've seen it in the quadratic formula? We talked about this one when we had that -4, the root of -4 on the first page. But now that you've seen it, why does it mathematically all of a sudden make perfect sense? Okay? The rest of the page. You got this, folks. You got this.
Yeah.
All right, that's my math.
Monday.
Don't forget to like and subscribe.